All right, so let's take a look at problem number 19. We're given two functions, f and g, and we're going to use that to build a new function. And this time our operation is one that we may not be quite as familiar with. You know, we're familiar with adding new numbers and subtracting numbers and multiplying numbers and dividing numbers, but for numerical values, for numbers, we don't have an idea of composition. But with functions, we do. And I like to describe this idea of function composition is to think of an assembly line, that you have a row, this assembly line of functions. So we've only been looking at two functions, but it could apply to more than two functions, a whole series of functions. The thing that you have to remember with function composition is that you don't read it from left to right, you go right to left, that you start with the second function. You start with this g, and you input values into g, and then the output of g becomes the input into f. So that's why I like to describe it like an assembly line. If you had more functions, if you had another function h, then the output of f would go into h, and you could continue that, you know, for whatever length that you want. But since it was a new concept, we've just kept it to two functions. But like I say, you can definitely imagine this output going into a new function, and then its output going into a new function, and having a whole series of compositions. And you would read it from right to left, not left to right. Now, just like with our previous work with functions, students kind of like to work with numerical values versus variables, or especially variable expressions. So in part A, it's not too bad of a problem at all. You're taking this -3 and you're inputting 3 into g, and then the output of g is the input for f. Well, what does g do to the input? What is g gonna do with this -3? G always creates a subtraction problem. That's what its job is. It takes the input, whether it's a simple number like -3 or some crazy complicated expression, and it's going to create a subtraction problem. So its first term is always going to be 3 times this input, and its second term is always the number 4. Okay, so here we're giving it an input that's a number. We're inputting a -3, so it's going to take 3 times the -3 and then subtract 4. So when you do that, you have -9 minus 4, which, if I'm doing my arithmetic right, is a -13. All right, well, now that output becomes the input into f. Well, what is f's job? F's job is to always take the input, no matter what it is, whether it's a simple number like -13 or something more complicated like some crazy algebraic expression. But it's going to take that input and it's going to square it, and then it's going to double it. So if we input -13, I'm going to square -13, which is 169, I think. Let's double check that. I'm pretty sure it is. And when you key it into your calculator, you need parentheses around that base. Yeah, and then I'm going to double it and get 338. So what this tells me is that if you input a -3 into this function composition, the output is going to be 338, if I haven't made a silly mistake. All right, so let's move on and take a look at part B. So now it's the same idea, the same type of problem, but they have changed the order of the composition. Now I'm starting with the function f, and the input into f is the number 4. I had to figure out what that output is and make the output of f the input of g. So I have to ask myself, what does f do to this input. What is f going to do with this number 4? Well, f is very consistent. It always takes the input no matter what you give it, and it squares it, and then it doubles it. It squares it and then multiplies it by 2. So if we input the number 4, it's going to square the number 4, and it's going to get 16, and then it's going to take 2 times 16, and the output is going to be 32, right? Now, that becomes the input for G. Well, what does G do to the input? G always creates a subtraction problem. No matter what you give it, no matter how complicated or simple it is, it creates a subtraction problem. And the first term is 3 times that input. And then the second term is always just minus 4. Okay? So if we're giving it 32, then it's going to multiply 32 by 3. And I think that's 96, and then subtract 4. And that's 92. So you're inputting 4 into this composite function, and the output is 92. All right. Now, I'll be able to check these answers. Well, the answer for part A, f composed with G, evaluated at -3. Well, see, here in part C, it's asking me to come up with the formula. Okay? So I'm going to use that formula to check my answer in A. Again, I start with the second function. And this time the input is x. Well, the output is g of x. And that becomes the input into f. And this is f of g of x. So what is g going to do with this x? Well, it tells me right here what g does with this x. If the input is x, the output of g is 3x minus 4. So that part's pretty easy. Now I have to figure out if 3x minus 4 is the input for f, what is f going to do to this 3x minus 4? Well, f always takes the input no matter what you give it, and f just squares the input and then multiplies it by 2. So if my input is 3x minus 4, I have to do that squaring before I double it. So I have to take 3x minus 4 squared. Now, many students are accidentally going to distribute that 2 through there, and that you can't. When you have an exponent, that means 3x minus 4 times 3x minus 4. And maybe you like to multiply binomials up through a table. But doing this exponent first, squaring this binomial first, I get 9x squared minus 24x plus 16. Now if I double all of those terms, that'll be my output. Oops. So 18x squared minus 48x plus 32, and there's my final answer. I claim that that's going to be the output of this function composition. If you input x, the output is going to be this crazy formula, 18x squared minus 48x plus 32. So let's see if that works for part A. In part A, it asked me to input, what was it, 3? I can't remember. -3. Okay. So if we evaluate this function, f of g of x, at -3, what are we going to get? Well, everywhere we have an x, we'll replace it with -3. So we've got 18 times -3 squared minus 48 times -3 plus 32. All right. Now, we've got 18 and -3 squared minus 48 and plus 32. 338. Now I hope that was the answer that I had in part A. Otherwise we've done something wrong somewhere. We got to search through it, or I'll have to stop and make it 338. So hey, I'm pretty confident now that that 338 was correct because I did it in got the same answer in two different ways. I applied the functions one at a time there, and in part C, I just jumped in and found the formula and applied it, plugged in -3 directly into the formula and got the same answer. All right. So yeah, here in part D, all right, I will be able to check my answer in part B doing the same thing. So this time, I'm starting with F, and I'm giving it X, and the output of F, we use the notation F of X. And then we replace, once we figure out what it's going to be, we can replace it with the expression. That F of X is going to be the input into G, and the output is G of F of X. Well, it's easy to determine what F evaluated X is because it tells us right there that it's 2x squared. And now we're going to have 2x squared be the input for G. So what is this formula going to be as the output? Well, what is G going to do with this 2x squared? G takes the input no matter what it is, and it creates a subtraction problem. The first term is 3 times the input. It gets that, and then it subtracts the number 4. So we're giving it 2x squared as the input. It's going to multiply that by 3, and then it's going to subtract 4. So 3 times 2x squared is 6x squared minus 4. Okay? So that's what our formula, that's what this new 6x squared minus 4. So let's check our answer in B. When we did this in B, G of this G of F of X, this golf of 4, let's evaluate this function at 4. So everywhere I see an X, I'm going to replace it with 4. So I've got 6 times 4 squared minus 4. And now this is not part of this. Here was our answer for D. I'm just checking my answer in B. Let's use my calculator so I don't make a silly mistake. And I've got 6 times 4 squared is 16 minus 4. 92. Is that what we got? Hey, 92. All right. So that checks. Now, is there another part of this? Yeah, there is, okay. This time, with our assembly line idea, we just have the same function twice, okay? This is asking us to come up with the formula for G composed with itself. So we've got this function G, and we're going to input X, and the output is G of X. And then the next function, rather than it being an F or something, it's an identical machine, an identical function, G, and so the output is G of X. Well, I'm not even using F in this part E. G of X is 3x minus 4. That's what G does to the function. It creates a subtraction. If you give it an input of X, it's going to multiply that input by 3 and subtract 4. That's what it always does. It takes the input, no matter what it is, it multiplies it by 3, and then it subtracts 4. Well, this time, we're having the input be 3x minus 4. So it's going to take that input and multiply it by 3, and then it's going to subtract 4. All right, so let's do that. Let's simplify that. G evaluated at 3x minus 4. Let's distribute this. 9x minus 12 minus 4. So we're getting as the output 9x minus 16, right? That's what this formula is. That's our final answer. So I hope that helps. Talk to you later.